We're going to give each person a pair of goggles to wear when you're going to use them just when you're doing chemicals.
You look big.
So that they don't splash up in your eyes, because some of them could damage your eyes. But when you're not wearing them, you can put them on your hat or around your neck. You can't hold them in your hands because they end up on the ground and they get really scratched, and then you can't see through them.
I want the new one.
Oh. All right, so we're going to start here on your first station, and we're going to check out the temperature of the creek. We're going to check the temperature of the air also, and we're going to check the pH of the creek. And we'll talk about what pH is, and I know you know a little bit of it because the last week's kids knew it.
Isn't it like acid stuff?
Exactly.
It sounds.
So, we're going to ask for volunteers as we move along, and what you guys need to do is take turns over the day at who's doing what. Okay, Jose.
Yeah.
Yeah. You're going to take this thermometer.
Yeah.
And on that side of the bridge, if you walk down, there's a place where the water's flowing over a log. Go hold that in there until I tell you to come back.
Okay. Oh, I think you're going to try and get rid of me.
Yeah, I did. Good job, huh? Now, and then I need another volunteer that can go down there. Okay, Annika. Take that and fill it to this line. And the thing is, when you do this, you'll get these all the time on this. You scoop them up with water, and you can't get it right at the line, so you can use this either to put more in or to take some out. But don't fill it like this, or you're going to be down there forever. Just use it for evening it out. So they're going to do that. Who's the next volunteer? Okay, right over there is a thermometer. You got to get it and read the temperature on it. That one is our air temperature. Yeah, see if you can read that for us.
22.
Okay, that sounds. This is in centigrade, because scientists use the metric system. So we're going to write down all of our stuff in centigrade, because if it was 22 Fahrenheit, would we be warm or cold? What do you think? It would be cold, wouldn't we? That would be below freezing. That's kind of like the nighttime in the winter here. But 22 centigrade is a little different. Okay, Jose, come on up. And read your thermometer as you come up, so you know what temperature the water is. What's our temperature? Bet you can do it.
13.
13 degrees, okay.
I see Annika in there.
Okay, she's getting hers filled. So, we're going to work on these pages. And actually, you guys are starting right at the top.
You really couldn't hear that much over there.
Yeah, that's what I said. You probably couldn't hear me when I yelled, huh? Because the creek is kind of noisy. All right. So in the data book, we're going to start here, and we're going to work down. But we're going to start and put the time in as 9 o'clock. And this is rotation 1. And you're going to do 2 tests at this one. Okay. So we got the air temperature was
22.
22, right? Okay. That's degrees centigrade. We're going to use this. Don't look at the red arrow. We're just going to use this to convert. And so centigrade's the inside one, and the 20's like here. So 22 is a little bit past 20. What would it be on the outside? Can you guys kind of see how that would work? You could go, this is 60 and this is 80.
Then that's 50.
What's between
70.
60 and 80?
70.
70. She's got it better.
I get confused with
Okay,
40.
so 22 is right around 70 degrees. So that's what you fill in for Fahrenheit temperature. So put 22 here and 70 there. And then we're gonna, did we take the temperature in the shade or the sun?
I want to do
Shade.
In the shade. So circle that. And then the water temperature was
13.
13 degrees centigrade. So let's look at this again.
Is that cold?
Well, that's... What did you put your hand in while you were down there? How did it feel?
I didn't put my hand down there.
Oh, you didn't? You touched it?
Yeah.
What do you think? Cold? Not too bad.
In the middle.
Okay.
So
So 13. Okay, look at the little numbers. You see where the 10 is?
yeah.
Yeah, 13's got to be a little bit that side of it. So up here in the bigger numbers, what would you guys say it is in Fahrenheit? Make a estimate?
50.
50? Yeah, that's pretty good. It's probably a little past 50, I would say. Let's go with, how about like 52? Okay, now we did the water temperature and how deep. Jose, how far underneath the water do you think the bottom of this was? An inch, 2 inches, 3 inches?
Say 4 inches.
4 inches. So record that. Do you think the water would be right here? How deep was it? 4 inches. Okay, so do you think the water, if we did it on the surface, do you think it would be warmer or cooler?
Warmer.
Yeah. And that's why we want to write down how deep you took it. That way when we can look and see if the next group said it was 16 degrees, but they took it on the surface, that would explain why the temperature changed so much. All right, so we have the temperature of the water. This little chart will give us a rating, and we're going to have these for everything you do here to see whether or not the number you came up with, what does it mean as far as the life in the creek. So 13, where does it fall? Is it warm water, mid-range, or cold water?
Mid-range.
Mid-range. 13, and it's the very lowest of mid-range, isn't it? Because if it was under 13, it would be cold water. So it's on the cold end of the mid-range. And here it tells you some of the things that might live. And one of them, it says, as far as the fish, it says trout and warm water fish. So when we catch fish in a little bit, we're going to see whether we find warm water fish, which would be, anybody fish here?
No.
You guys don't fish? So a warm water fish is something like a bass. Have you heard of bass?
Yeah.
Yeah, you've heard of them. And a cold water fish is like a trout. So they live in different temperatures of water. Okay, then we have another question in your book to fill in is, why do you think I'm going to have Jalen?
Yeah.
Okay. I get the names.
She's
She's going to do the drops, and when she does them, she's going to hold this totally upside down and count the number of drops. And the number she needs to put in here is 10. Okay, Jalen, you got to get up here where I can hand these to you.
Put your goggles on first.
Yeah, put those goggles on. Yeah, before I hand you the stuff.
Make sure you don't fall
Put
off.
10 drops in.
Hold on. Don't do it without me.
Yeah, count carefully. I think everyone can count to 10 pretty well.
3, 4, 5, 6, 7, 8, 9, 10.
Okay.
It's green and red.
I'm going to switch you. I'm going to give you that cap. Put that on there gently and hold the top and shake the chemical into the water. And it's going to change it a color. Depending on what the pH is. So what is pH? You guys,
It's like acid or something like that. I can't
it's
remember.
whether it's an acid or a base. And everything has a pH. And the numbers go from 1 to 14. So the low numbers are the acids, and the higher numbers are the bases. And does anybody remember what neutral is? What's the middle one? What number?
6.9.
Huh? Which?
7.
7. Yeah, 7.0 is neutral. And that
Oh,
is
6.
what pure water is. If we have distilled water where they've taken everything out of it, it's going to be pH 7. So let's pass that this way. And you can take the gloves off. When you take your gloves off, wait. Watch this, everyone watch. You don't want to touch, you want to flip them inside out. You don't ever want to touch the part that could have the chemicals. So you want to touch them here, it's inside out. Then put this one in your hand, and if you do this one inside out, you got them inside each other. Color matching. And this is how this test works, is you match it to which color. So which box?
Green.
Green box, okay. These are the acid pHs, and these are more the basic and the neutral pHs. So which side do you think is closer?
Second one, the 7.9.
That one. And so I'm putting it inside, and then you're going to look at it and see which of these 4 that are on either side do you think matches the close. So as you pass it around, look and decide which number you think it is, 7, 7.5, 8, or 8.5. And keep it to yourself. as it goes around. Do it kind of quickly, and then we're going to just see what you all come up with. What happens if everybody says their number out loud? Does it influence the next person? Mm-hmm. It does. Anyone say 8 or 8.5, the bottom ones?
8.
You said 8? Okay, now you said what?
8.
8. Okay, I got 2 8s. Anyone, let's just go backwards. Anyone say 7.5?
I say both of them.
1, 2, 3. And anyone say 7? Okay. Well, you know what? Most of you thought it was 7.5, and we had a couple on either side. So we're just going to use 7.5 as our answer to the pH of the water.
To me, it looks like 7.0 and 7.5.
Yeah. So here we're going to fill in one more set. The time, you can still use 9 o'clock because we're on the same rotation 1. And then it asks, what is our pH sample? And we got 7.5, which is right here at neutral, just a little bit past. And if you look, almost everything can live in that pH. It's a great pH for living things. So what do you guys think? You know, we want to figure out why pH is important. So if the water was pH 4, would there be much living in there?
No.
No. If it was pH 9, would there be much living?
No.
You know, there isn't a lot that can live in pH 9. A few things. You'll find some algae and some bacteria, and maybe a few of our native fish might live there. But in general, most organisms like to have a pH of between 6 and 8. And that's your next question on there. That's kind of the range that living things tend to be able to survive in, is pH 6 to 8. Okay. And then I think that, are we done?
Yeah.
Okay, one more little thing to look at. And Mr. Holland told you about this guy, right?
Yeah.
Yeah, do you remember his name?
You know.
It's a
I don't think he told
Giardia.
us.
He didn't tell you the name?
No.
Okay, this is a Giardia, and it's 1,000,000 times magnified. So this little picture here shows what, if you put it water under a microscope and it had Giardia in it, what it might look like. See, it doesn't really totally look like this guy, does it? You see the microscope picture here? That's kind of what you might see under a microscope. And this is a microscopic organism. You need a microscope to see it. And it's something we're not looking for while we're out here. We don't have a microscope out here, so we're not looking today at anything that is living in the water. We're only testing the chemistry. So as you go along and you find out your tests say the water's pretty good, you got to remember that you're not looking at living organisms. And living organisms in it are the kind of things like bacteria and these guys that can make you really sick if you were to drink the water.
What if you drink it on accident?
Well, if you drink it on accident, your chances are, you know, maybe you get one, maybe you don't. How many of you drank water out of a creek somewhere without treating it? And did you get sick? No. So, you know, not every time, but if you do get sick, this makes you really sick.